What's up, guys? This is a final review video for CS 1110. I'm going to try to make this one a little bit faster because I know last time I droned on for a little bit. Basically, I'm just going to be following this big list here, which you can get to if you go to Schedule and Control F Topics List, and you go here. And as I've said before, and on Piazza and stuff, the best thing I think that you could do, or the thing that worked for me when I was in the class at least, was really just go down these bullets and know what everything does and all of its little quirks and everything, and because then you'll have all the tools that you need. And then when on the test, when you have to solve the little logic puzzles that work with these things, you'll have all the tools that you need to do so. So I'm just going to be going through these, and then yeah. So we got the first one up here, and that's just saying okay, everything on exams 1 and 2 are on the test. So I'm actually not going to go through these because I did them on my previous videos. So if you want to see that, just go on the. I think I'll put this on I have a playlist of all the things. Just go on there and see the other ones. I could go on YouTube and play them for you right now, but that would be ridiculous. So okay, so then so yeah, and it's cumulative, and yeah, no turtle. Don't worry about turtle. That'd be funny if we made you learn turtle syntax. All right, so the next thing is try except. So try except is this really awesome way to be totally lazy in Python. Actually, I guess it has some yeah, it has some uses definitely, but it's a cool way to be lazy too. So here's an example. So we have basically it looks like one of those if statements or while or for whatever, and it'll say basically I want to, we have try and then you have except. Actually, I think if you don't put except, I think it gets mad. Let's test it out. And then yeah. So see, I think it's looking for except there. So I'm gonna put that back. So now, basically, what it's gonna say in the try section here, it's gonna say try just do this code, hope for the best, and there might be an error in here. That's just what you're saying when you're doing try. You're saying there might be an error in here, but go ahead and just do it anyway. And instead of crashing my program, like for instance here, if we take int of a string that's not an int, that will give us a value error, right? I'll do that real quick. So if I do this and do int of not an int, it's going to say, oh, we got a value error, which is a special kind of error. And remember, errors comes in all kinds of different types, and this is called a value error. And so basically, this is you've probably seen it before. So yeah, so basically, we're saying try this whatever's in here, and you can put multiple lines of code in here. Like we can I don't know, print hi afterwards. And then we're going to, if there's some kind of error here, this is kind of interesting. So what it's going to do is it's going to try this first line here. It's going to say, take an int of a string. And that is an error. So then it's going to go down to this except case. And it's not going to print hi, right? Because it's going to immediately see the error and go to the except part. And it's going to print out whoa there. So we should see just whoa there, right? So let's give it a shot. Yep, just whoa there. See? And what's interesting is that you could do a little bit more, go more depth in this. So let's say that you have a bunch of lines of code here, but you only want it to fail if you're taking an int of a string. Because say there's other code that could fail, but you don't want to just always say except print here. Because what if you have some other code, blah blah, right here that you think is totally fine code, and basically this one's the one that's throwing the error, and then you're gonna be really confused because you're like, wait, but this isn't, this wasn't failing right here. That's not why I'm getting here. But it turns out there's some other syntax error you had. Because remember, literally, if you put literally anything in here, see, this is not code. This is just garbage, right? And this is throwing my except. So then again, if we said, okay, we'll take int of 6 or 7, which is totally fine. When we have this garbage in here, it's still going to do this whoa there, right? Because it's seeing an error here and it's immediately going here. So how can we fix this? I'm going to put that. Actually, we'll leave this here. So let's do 7.6. You cannot take an int of a string, right? So right now it's doing. Well, give me a sec. So yeah, we have this we're taking an int of a float string, and that is not allowed. That's going to throw a value error. Let's try that like I did before. So I'm just going to paste this in, run this, and see we get to a value error. So what if we want to specify to Python that we only want the except case to go if there's a value error? Because see, we want this garbage to actually crash because this is not code, right? So what we can actually do is say except value error in here like this. I think, this might not be the right thing. Yeah, it's totally fine. I thought it would light up in blue, but it does not. So basically, so if we run this, then look, it says I'm taking the int of float, which we're not allowed to do, and it sees the value error and it prints out whoa there, right there. But what if this is totally fine? What if we make this be int of 7? Because int of 7 is not going to do a value error. So like before when we had this, it just immediately jumped to this anyway. But now we don't see a value error, so it's going to say, hey, you can't do this garbage. This isn't code. So see, it was only looking for the value error, but if we just put except here like this, then it just, whatever you put in there, if it causes an error, it just immediately goes to except. And we could do multiple of them too. Hold on. Yeah, see, we can do multiple errors here. So see, this is another kind of error. If you do like 5 divided by 0, you get a 0 division error. So let's go ahead and put that in here. 5 divided by 0. And then I'm going to put another except right on here and say except. I'm going to copy this 0 division error. If this happens, we want to say print you can't divide by 0. So then I have a little. There we go. So if we run this, it should. So it's going to see this because this causes a name error, which before with that garbage there. But what's going to happen is going to see this this value, this 0 division error before that. So that'll actually go to our except case. Because remember, when it goes to an except case, it doesn't run any other code in here. It stops right here and just immediately goes to there. So see, we're gonna. Oh, whoops, gotta run the right thing. Yeah. So see. Oh, I forgot my colon too. There we go. And so yeah, it says you can't divide by 0, and it didn't get mad at us, even though we have garbage in here, because it just went right to here and it said it stopped right there, and it went immediately to the except case right there. Now, however, I bet if we move this above that right there, then it will crash and get mad, because what's going to do is going to see this. It thinks this is some kind of variable that we're just we're just saying like x on a line. So it's looking for this variable, which does not exist. So that's going to give us a name error like before, and we did not have an except case for a name error. So this will actually just get mad and yeah, it just says crashes our program instead of going to the except case. Now I'm busy making a puzzle for you guys, but I found something interesting. It looks like if you have some kind of syntax error, it's going to crash it no matter what. Let me, looks like that one's being highlighted. Yeah, it looks like, even though I said, hold up. Yeah, so see, so see, we have like, this is totally fine, that's not going to cause an error, right? Oh, I'm like giving you away the answer, but, and then 0 division error, normally this would go immediately to here and say you can't divide by 0, but see, when I run it, it just says invalid syntax. It doesn't even do my syntax error except, which is like what? But it looks like Python, when it sees syntax error, and this is probably like when it's scanning through here, whatever. Actually, that's what I'm saying. But yeah, I guess it just gets mad with that. So don't. I mean, this makes sense because normally when you're doing try and except case, like the purpose of these is to catch errors that you did not. They aren't really your fault, I guess. Like basically, like normally when you have like things in here, it's like say you're saying like x equals my function, and it's like returning some value to x, and there might be a value error from this function based on like what the user puts in or something, and it's not really your fault. Like this code is solid, but it might just be that there's a boundary case that's like gonna run this. But basically, it's not really for like syntax errors, like things that are your fault. Like if you said like x x equals int of, or say you forget it, the other parenthesis here, like you have a missing parenthesis, that's going to be like immediately, hold up, I was getting confused because there's a parenthesis there, but basically this is your fault, right? You did not, you coded wrong, like that's not really what these try excepts are for. Really, it's like, say you're doing x is, here's a good example. If you say x equals input, give me a number, and basically we're going to cast this int to right there like that, and then we can say like except with the value error, we're going to say like whoa there, enter a number. So if I run this and I say it says give me a number, and I can put in 5, that should be totally fine, right? But if I put in pizza, then it's going to say hey, give me a number. So that's so I'm kind of on a tangent here, but I was trying to say that basically these try except cases are for errors that are not your fault. They are due to like some unforeseen thing that you think like, it might error if X happened, then that kind of thing. All right, I have a puzzle for you. So I have a try loop right here. And basically, what I'm asking you is, what does this print out? So if you want to just pause the video and try it, go ahead. But so we have this try block here, and I have x is the int of pizza, and then we multiply that by 0 over 0. And then the first one I have listed is 0 division error, and then the second one I've listed is value error. So what is this going to print out? All right, so give it a shot. And I actually have the answer down here the whole time, I just realized. But yeah, it's going to print out whoa there, because even though this one is listed second, this is the first error it gets. And remember, if we put code before this, if I say print like 4 or something, that is going to print 4 before this, because it runs all the code, and it actually like literally does, like it runs the code, but as soon as it gets something here, it's going to do your whatever error it finds first. It's going to go down to here and see if you have accept the errors. And then sometimes you can have like a general one at the very end, like you say like accept, like if anything else goes wrong, then I want you to print like, LOL IDK what happened. And that'll catch all errors at the bottom. So say like you have multiple errors that could happen, you want to handle them differently, and then this is like your capture all. But remember, this is dangerous because you could have a syntax error in here. Actually, not a syntax error, but like something that you did not foresee that is your fault, that just needs to be debugged, and then it's just going to go to this every time and not crash when you want it to crash. Because crashing is actually good in terms of debugging, right? All right, so now we're going to do some GameBox. So remember, for a lot of GameBox stuff, you can just go to your go to the assignments and go down to. I got a low battery. Good thing I got my charger right here. Boom. All right, and then so yeah, you can just go down to the project, and then you can Control F this for the GameBox docs, and we'll have both of these things right here, and then look some of this stuff up. So I'm trying to decide if I should actually model this stuff for you. Maybe. All right, fine. I guess I'll see how it goes. I'll play around with the game. So basically, I'm going to go to basicgame.py. You can Control F on the page. I'm just going to copy right this in here. What does this look like? Probably the best game in the world. Let's see. It's going to take me over here, and then the Python logo. Interesting. Yeah, so that's a great game. So let's play around with this, I guess. So what's the first thing you gotta know? Remember, the GameBox stuff on the project is probably not going to be like super specific. I don't think. I think it's going to be like general knowledge. But I would definitely know the stuff on the topics list, because this is the good list of all the stuff. So what do we have first? We have import Pygame and GameBox. So what does that do? So remember that Pygame is a module that is like in the depths of your computer, like with like math and other random and URL-lib, all those like files that some higher up coding guy wrote or whatever. And then GameBox is something that Professor Tyganovich actually wrote, and that's normally the one you have to have in the folder with you, because it's not buried deep in your computer like the Pygame. It's like a file that you just have in your directory that you are working in. I know I have GameBox on, this looks super cluttered, but here's my GameBox on my desktop. Oh, I did not want to open that up. But actually, I will. Yeah, so this is like super long. Basically, this is just translating the complicated Pygame into stuff that we can work with, like saying like touches instead of like other dot left self. This self is actually has to do with object-oriented stuff in Python, which is crazy, and I don't even know how to do that. So yeah, so GameBox is fun. And then what is this? Oh, don't look at my Flappy Bird. That's from when I was in here. That's actually in the old GameBox too, I think. So then let's see. So then the next thing on the list, we have touches. So I guess what I'm gonna do is I'm gonna say what I think it is, then I'm gonna test it out and make sure that I'm right. Okay, so box 1 dot touches box 2. So this is like a true or false thing. It's gonna return true or false, this statement here, right? And basically it's saying, is one of my game boxes touching the other game box? I mean, it's kind of obvious, right? So I gotta find. So yeah, see what I did is I just took his logo thing and I duplicated it, made logo 2, so it's going to be exactly right overlapping. And then basically I just drew both of them because why not? And then basically I'm just going to print out what this returns, the logo.touches logo 2. So let's run this real quick. Oh, that is the wrong command. There we go. And then I'm just going to X this out. Actually, it's 2 things overlapping here, and you'll see that it printed out true a lot of times. Remember, this runs really fast, right? So I print out true because box 1 is touching box 2. Right. So then now I can say box1 dot move to overlapping box2. So basically, what this is going to do, I believe, it's like so basically. You have to remember with this one, because you know what it does. Like, it's going to move one of them to stop overlapping the other. But which one is going to move? What's going to stay stationary? So I believe that because it's being called on box 1, we're saying box1 dot move. Basically, look at this. It's saying move box 1 so it stopped overlapping box 2. So I'm gonna change the image on logo 2. Do I have an image in here? I have someone's. Let me find a good one. All right, I have this Luther.png in here, so let's go ahead and put that in there. And I have to copy it so I can say, because remember, can either be a URL or like a file name, right? So Luther.png. Let's just make sure that that's up there. Yeah, there's overlapping there. So then, I'm going to move. So I'm going to say, let's see, we're going to move logo 2. I'm going to copy this this little code up here. So we have box1 dot move to stop overlapping box 2. So I'm going to do this. Basically, so the first time it's going to draw them, but that's going to move them. So we're basically just going to immediately see them no longer overlapping. But which one's going to move? So when we run this, initially, they were overlapping, and it looks like they're right around in this area. So which one is going to move from that area? So I'm actually going to make okay. So then I'm going to do this, and then I'm going to say, let's see, logo 2. So let's say we're going to move Tykanovich over so it's no longer overlapping the Python logo. So we're going to say logo 2, so move logo 2, which is Tycho, we're going to move him off of the Python logo. So see this one, see how it just jumped up there? So initially it's right there, and we can move that one. So see, it jumped, so it's no longer overlapping this nice logo there. So there we go. All right, now we are dealing with speed X and speed Y and move speed. Okay, so so speed X and speed Y are variables in the game box. So say we have I'm going to rename this to Tycho, and then let's say Tycho and Tycho. I'll do this, hold on. All right, so we're looking at speed X and speed Y. Now, if I go in here, it's going to say that speed X, it says you're setting the speed in X and Y. And basically, so what is speed X? Is it an object in memory somewhere? Is it a magician living in your computer? Like, what is it? So basically, all it is a variable. It's like just a convenient, it's conveniently named speed X, but it could be called pizza or something. So basically, see, if I say Tycho's speed X is this list, which is weird, you'd think it would be a number, right? This does not crash. This runs just fine. So are you going to say speed X equals, range of, whatever you want it to be, a range of 900. Sure, speed X is a range. Okay, makes total sense, right? But basically, this is a variable. Anything that you can do Y equals something, you can do for Tycho.speedX something. Actually, I'm going to try something. I think you might be able to say, like, Tycho. This is very bad. Don't do this. Say Tycho.pizza equals 0. See if this crashes. Yeah, so I think... So this says, oh yeah, so if you do one that doesn't exist, like so speed X is defined in the game box somewhere. I'm sure it'll say like, oh yeah, by the way, we're going to have this speed X variable that we can use for things. But if you make your own, like if you do one that doesn't exist, you're probably going to get this message over here, and you probably see this on your game box. It'll say, info, added pizza to box. Basically, you're basically having a variable that is living inside of your game box. That you called this, and now since it didn't exist, it said, hey, I just created this variable that didn't exist, and now you can put whatever you want in it to. So yeah, that's all speedx is. It's just a variable. You could have your own variable be something, but it's kind of nice to have your variables like linked to the things that they're acting on, and which you can do with objects, which is what game boxes like Tycho are. Tycho is actually an instance of never mind. I don't want to go into that. That's 2110 stuff. So then. Let's see, so we got speed X and speed Y, same thing. It's just, I can set speed Y equal to a range, fine. I don't know why you would ever do that, but it's all it is a variable. And basically, that's the point of this. The point of understanding that is you don't want to be afraid of what the code is. That's weird. I shouldn't say. You want to know what the code is. What am I saying? It's dumb. Okay, so. I should plan these videos more than I do. So yeah, so now we're gonna look at move speed, and I have no idea what that does. So we're gonna look that up. Move speed. So this is going to move at current speed. So I believe. Oh yeah. So what this thing does is, whenever I work on game projects, I say don't ever use this. But unfortunately, it's on the test, so you have to know what it is. But don't ever use this in real life, because basically what this does is, say we have. Unfortunately, I don't have Microsoft Paint on my laptop, so here's like this terrible version up here. But basically, what move speed is doing it, some of you probably taken physics. You know, when you have those free body diagrams, where you'll have like your x component and your y component on the diagram, and then if you do what this, I can't undo on this either. But basically, this is going to turn into your box going in like this direction, right? Because if you add this, this is terrible. if you add this vector to this vector, you end up with a diagonal vector, right? So let's try that out. So let's say tycho.speedx equals 5, and then tycho.speedy equals 5. So basically, we have a vector of 5 in the up direction and a vector of 5 in the other direction. So what you can actually think of it as is going to be a diagonal in this direction. Actually, I made a big mistake. Can you see what it is? Can I delete stuff on this? This is terrible. Oh, man. Okay, I can't delete anything. Okay, so give me a sec. Oh, wait, you know what? I know what to do. I'm gonna make the whole. I remember my Paint days. I can just do this, and then I can. Yeah, there we go. Okay, so what are we gonna do? What was I doing? Yeah, so if you have a vector in this direction, this is 5, and then you have 5 this way, then that's going to be vector. And what I was saying, what I was trying to say is that remember that positive y for speed or whatever is downwards, right? I made that mistake. So we're gonna have a speed of 5 in the down direction. Some of you may have noticed that. Then we're going to have a speed of 5 in the x direction. Basically, that's going to make a vector in this direction. And what's that speed going to be? Well, you know, if you do the Pythagorean theorem, then we have 5 squared plus 5 squared. And then we have to take the square root of that, right? So it's going to be square root of 50 in that direction, which is about 7 in this direction. It makes sense. You know, you have, yeah, whatever. So let's try that. So, and basically that's another thing. When I was saying the speed x, speed y was literally just a variable. The only thing that's special about it is that this move speed function is going to like work off of those. So if you have like tycho.pizza or something, that's not going to like relate to this function. So that's why you couldn't, if you wanted to use move speed, you couldn't like, say you just wanted to store your speed x in like your own like my speed x, which you could do because you'll see how we use it later. It's just like having a variable. But if you're using move speed, then you're going to need to have it on these ones. So cross your fingers. I hope this works. But yeah, yeah. So Tycho. Oh yeah. So basically, it was still stopping. It's trying to move in this this downward direction, but it's still overlapping this thing. And then once it gets over the game box, it's going down that way. So let's comment out move stop overlapping, and it should just immediately go in that 7 direction that we thought down there. There we go. Okay, so that's move speed for you. And basically, this is going to the only thing this is doing, and this is why I hate move speed because there's no reason to ever use it. So you say what we do is we say tycho dot x plus equals tycho.speed x, okay? And then we say tycho.y plus equals tycho.speed y. So it's going to go in those. So basically, these two lines and this line are exactly the same. They're going to do the same thing. If they don't, I'm going to be really mad. But yeah, just goes down in that direction. And I think it was the same speed, right? Like, actually, I can test that if I move the other one, right? Yeah. So what I did is I set the logo.speedx and logo.speedy, and logo is going to move by move speed, but then Tycho is going to do the exact same thing, but with different wording here. And you'll see that they move the exact same rate. They're doing the same thing. See, both Python and Tycho are going down that way. So there we go. And so yeah, that's move speed for you. It's going basically. It's basically what move speed is doing is it's adding. And I guess this goes into like how Gamebox stuff moves. And I don't know if you have to know the stuff this in depth, and you probably know from your Firebird. But remember that this tick function is looping over and over and over again really fast. And basically, what's interesting here is usually you draw these down at the very end. But so basically, when this thing goes through, it's going to the way it's set up right now is it's drawing Tycho in the logo, and then it's moving them, and then it's displaying them where they were before. But then on the next one, it's drawing them at their new position. And basically, that's the way. So normally you put these down here. It makes more sense to me if I move down there. Make sure this didn't change anything. Yeah, it's still move down that way. So then, so basically, what it's doing is it says, okay, we have so these are global. So these are just gonna chill out here. And we have this function that's running really fast. And so basically, we have we're moving them according to this thing, and then we're drawing them. So we're moving it and then drawing it, and then moving it and drawing it. Move, draw, because that's what this is doing is going really fast. How did I do that? My cursor just got really big. I have no clue how to do that. Okay, so yeah, so it's just that's how things move. We're just gonna move it and then draw it, move and draw it, and it gives an illusion of moving because it's going really fast, kind of like a flip book if you ever have that. That is. I thought that button would run it, but oh yeah, so there we go. Yeah, so that's how move speed is working. It's just doing the exact same thing as that, and I feel like I've just repeated myself 10 times. So let's move on. So now we have camera.draw box. What is this doing? So if we do not camera.draw one of the things, it will not draw it. So if I get rid of this Tycho, it's going to not draw it and just do the Python down that way. So yeah, so basically what camera.draw is saying, hey, when I do display, make sure to include these things in there too. Because remember, if we don't have display, nothing will happen, right? Like, it's going to be a blank box, right? Because we didn't display anything. Even if we drew both of these things, it just, like, it doesn't display them, right? It says, get ready to draw these things, and then don't ever do it. But yeah, that's camera.draw. Just going to draw those things, right? I feel like you guys understand that. So yeah, so we have draw and display, the same thing I just said. And then, okay, so timer loop, ticks per second, and ticks. And the basics of how to write a ticks function, including ticks, arguments of collection of key, all this stuff. And then, yeah, so what is this all saying? So basically, I think what this bullet is trying to say is, basically, I would memorize maybe, if you go to schedule, I am not in the right place. Schedule, and then if you go to basic game, right? Yeah, this shows you like the basics of how to just run a tick function. I just copy paste every time, but I think it might be a good idea just to memorize the basics of it. So maybe if there's I don't know, I don't want to give any examples, but yeah, just know it for the exam, I guess. So then. Yeah, so what are each of these components here? So gamebox.timerLoop, basically this is, normally when you call a function, you would say like tick, like this. I wonder what happens if I do this. Let's see. Ooh, it displayed it for a second. You see that? And it's, actually, just kidding. What if I do, actually I don't have key, just, never mind, it's awful. Yeah, so basically, instead of running it like that, we have to say, hey, Gamebox, I want you to set up a timer loop, and I want you to have a tick frequency of 30 per second. I believe it is per second, right? Let's say back there. Yeah, ticks per second. I'm going to do 30 of them per second, and I'm going to pass in the function tick. Because remember, you can do things with function. Like I can say print. I'm just going to say print. I think you can do this. That's going to say it is a built-in function print. Because remember, you can do things like that. You can say like, you can just use functions like they're like variables, right? So that's how we're like passing that in there. But I don't think it's weird of that. So yeah, so basically the function, the point of this whole line is saying, hey, run my Gamebox, like run this function, and we're gonna do it 30 per second. And I want the tick function that we're doing, because remember, tick isn't anything special. I can name this pizza if I want, and then I can put pizza in here, and it will pizza. It will run just fine. I'm like 90% sure. Yep. So basically, it's like you're running this timer loop has to be timer loop, right? Because it's a function within GameBox, and it's basically running this function 30 per second, whatever function you called it. I'm going to put that back as tick. There we go. And then, so yeah, that's basically the point of that. And the basics to write a text function, well, I think I'll leave that to you, but I guess the basics I can think of off the top of my head is that it's called something. You have to have this argument called keys, I believe. Actually, check this out. So you can actually call it whatever you want. So if I say tick of pizza, then let's say I'm going to say if what is it? Pi. What is that? Like the in keys syntax. Oh crap. Yeah. Okay. So maybe you do like if pi game got up in keys and the up arrow was being pressed. So let's put this in here. But what's interesting is if we called it pizza instead of keys, then we'd have to say in pizza, and then so now we can test this out. So I'm going to press the up arrow a bunch of times, see if it prints that out. So yeah, it prints that up. So basically, you usually call this keys, and it's basically the parameter that this is taking that you can put in there like that. So yeah, and if we put the print function in here, I bet it would get. I'm interested to see what happens. Let's see. Oh, okay, that's weird. Don't do that. Okay, so yeah, because you can remember this is an argument that takes in functions, so you can put like int there, and then oh, actually that's not good because it's not a. I don't know what's going on. Don't do that. Never mind. I'm just messing around at this point. And I said this video is gonna be faster. Now it's already 30 minutes. I'm gonna go watch part 2.